If you are visiting our channel for the first time, please subscribe first to get the latest updates. In our previous lecture, we have seen how you can apply a partial fraction decomposition in case the given fraction has linear factors. That was the rule number 1. Today we will discuss the rule number 2, according to which when you have a fraction that is having a denominator with repeated linear factors. Now, what is meant by repeated linear factors? Now, it is clearly shown here that in the example, here x minus 1 is having a square. It means x minus 1 is repeating. So, when a certain factor is repeating itself in such a way that it has a square in this way, then we can say that the given factor is repeating itself. So, how you can solve such fractions and how you can decompose into the partial fractions? Let's see. So again, we have to follow all the steps. As the step number 1 is you have to check whether the given fraction is in the proper form or not. So it is clearly shown here that it is already in the proper form. So I'll write it as already the given fraction is in proper form. And if it is not, then as you know that in our previous lectures we have seen, if the given fraction is not in the proper form, you have to convert into the proper form by using long division method. So it's in already proper form. Then we have the step number 2. In step number 2, you have to factorize the denominator to get the factors. So let's see whether the given fraction has a denominator that is already factorized or not. So it is clearly shown here that it is already in the factorized form. We have a factor x minus 1 and x plus 1. So we can say that we have two factors from here. So we need not to factorize the denominator here. So we move towards the step number 3. In case it is not factorized, you have to use the methods of factorization in order to solve it into a simpler form of by using the factorization. So step number 3 is write each factor separately under unknown variable, as we have already done in our previous lecture where we have the linear factors. So write each factor separately under unknown variables. Now what is different in this case or in this rule as compared to the previous one? The difference is that we have to write the factor that is repeating 2 times with a different variable. So I'll write while the one that is repeated will be written twice. That is the one with square or repeated written twice. Let's see how. This is the only step where the rules differ from each other. All the four rules will differ from each other in the step number 4. So let's see how you can write it as 1 divided by x minus 1 whole square and x plus 1. So it can be written as a divided by x minus 1 plus b divided by x minus 1 whole square plus c divided by x plus 1. So this is how you can write the factor that is repeating itself by using an extra variable in such a way that I have written. So this is the form of that we have to find. So this is the form of partial fractions, and this is the equation number 1, and we have to find a, b and c. As in the rule number 1, we were having only the 2 variables, as we were having the 2 factors, but in this case each factor is repeating, so we have to increase the number of variables. So move towards the step number 3, move towards the step number 4. What is that? We have to take the LCM of the right hand side of equation 1. So let's write it down as 1 divided by x minus 1 whole square into x plus 1 equals to a divided by x minus 1 plus b divided by x minus 1 whole square plus c divided by x plus 1. Now let's take the LCM as x minus 1 whole square into x plus 1. So I'll write as a into x minus 1 into x plus 1 plus b into x plus 1 plus c into x minus 1 whole square, as you know how to take the LCM. Then what we have to do? We have to cancel the similar terms on both sides as like this. And now the expression will be written as 1 is equals to a into x minus 1, x plus 1 plus b into x plus 1 plus c into x minus 1 whole square. And this is the equation number 2. So this was the step number 4, and it can further be simplified as 1 is equals to a into x square plus x minus 1 plus b into x plus 1 is bx plus b plus c into x minus 1 whole square. I will open the formula as x square plus x square plus 1 minus 2x. As this is the step, this step is also different from the previous one, as we have to open the brackets and multiplying the a, b and c with the variable and the constant in order to compare the coefficients. The number of factors are 2 because one is x minus 1 and the other is x plus 1. Then how you will be able to find the third factor? For in case of finding the third factor, you have to use the comparison of coefficient method. Let's see how. Currently, just you have to see how we can simplify this this equation as 1 is equals to a into x square minus 1, as it will be cancelled out, plus bx plus b plus cx square plus c minus 2cx, and it will be like 1 ax square minus a plus bx plus b plus cx square plus c minus 2cx. Now we will combine the terms that are alike, as 1 is equals to ax square and cx square will be together as ax square plus cx square. Then we will combine the x terms as plus bx and minus 2cx, and then the terms that have no variable as minus a plus b plus c. So this is the equation number 3 that we have got. Now we have to find the value of a, b and c. Let's see how. We have the next step as step number 5. The second last step, right? Find a, b and c. Now how you can find? Let's start from the factors and putting the values in the equations. As first we have the factor as x minus 1 equals to 0. That will become x equals to 1. This is the factor number 1. And another was x plus 1 equals to 0. It will become x equals to minus 1. So these are the two roots that we have found from the factors, and we have to put these values in the equation number 2 in order to get the value of two variables. Now currently we don't know whether it will be a, b or c. Okay, so let's start by putting the values. As the equation is basically, first let's write the equation, then we will solve it further. 1 is equals to a into x minus 1 into x plus 1 plus b into x plus 1 plus c into x minus 1 whole square. Now we have to put the value of x is equals to 1 first, then we will take the value of x equals to minus 1. Put x is equals to 1. So I'll write 1 is equals to a into 1 minus 1 into 1 plus 1 plus b into 1 plus 1 plus c into 1 minus 1 whole square. It will be like 1 is equals to, the whole expression will be 0, as 1 minus 1 is 0. 0 plus 2b, as 1 minus 1 is 0, then c also will become 0. It will be like this. So we will have 1 is equals to 2b. That means b is equals to 1 by 2. So we have got the value of b is equals to 1 by 2. Now put x is equals to minus 1 in the same equation, this one, as 1 is equals to a into minus 1 into minus 1 plus b into minus 1 plus 1 plus c into minus 1 whole square. So what we will get? 1 is equals to, it will become again 0. So 0 plus, it will also become 0, minus 1 plus 1 is 0. And then we have left with c into minus 2 whole square. So it is like 1 is equals to 4c, and the value of c comes out is c is equals to 1 by 4. So we have got the value of another variable b and c. So we have the values of b and c. But what about the value of a? How we can find that? As we have only two factors, so for finding the value of c, for finding the value of the third variable, that is a, we have to make use of the method of comparing coefficients. Let's see. For finding a, compare coefficients in equation 3 that we have already found in our previous steps. In equation 3, let's write it again for your convenience. So the equation is 1 is equals to ax square plus cx square plus bx minus 2cx minus a plus b plus c. Now this was the equation, and we have to compare the coefficients on both sides. Let's see how. We can further simplify it as a plus c x square plus b minus 2c x minus a plus b plus c. Now we have to compare the coefficients of x square, x and constant. So as we have to find the value of a, so we will compare the value of the coefficients of x square. As the coefficient of x square on the left hand side is 0, as I can write it as 0x square plus 0x plus 1. So the coefficients of x square here is 0. So I can write it as comparing coefficient of x square as 0 is equals to a plus c. As we have already found the value of c, that is minus 1 by 4, as c is equals to minus 1 by 4. So we have to put it in the equation as 0 is equals to a minus 1 by 4. So a is equals to 1 by 4. So we have got the value of a as well. Now we have the value of a, b and c. What are those values? Let's write them as a is equals to 1 by 4, b is equals to 1 by 2 and c is equals to minus 1 by 4. Now we move towards the last step where we have to put all these values of a, b and c in the equation that we have found in our step number 3. So the last step is step number 6, where we have to put value of a, b and c in equation 1, as a is equals to 1 by 4, b is equals to 1 by 2 and c is equals to minus 1 by 4. So let's write the equation. That was the equation number 1, as 1 divided by x minus 1 whole square into x plus 1 is equals to a divided by x minus 1 plus b divided by x minus 1 whole square plus c divided by x plus 1. So let's replace a, b and c with their values, as a is 1 by 4, so 1 by 4 x minus 1 plus b is 1 by 2, 1 by 2 into x minus 1 whole square minus, as we have the value of c as minus, so minus 1 by 4 into x plus 1. So this is the partial fraction of the given resultant fraction that we have found by using the partial fraction decomposition method for repeated linear factors in the denominator. So in our next lecture, we will see how you can solve for partial fraction decomposition in case you have the denominator with the quadratic factors. So thank you. Thank you for watching. If you like this video, please don't forget to subscribe our channel math.com for more updates. Thank you.